Welcome all to this module of Big Data University. My name is Ben Connors, and I'm the Worldwide Head of Alliances for Jaspersoft. We're a business intelligence software provider and a close partner of Big Data University. We'll be providing this reporting and analysis on Hadoop course module for Big Data University. Jaspersoft integrated our software with a wide variety of SQL and NoSQL data sources, including multiple integrations with Hadoop. In this lesson, I'll explain the need for reporting and analysis on Hadoop, and I'll discuss several architectural approaches to address various use cases for Hadoop reporting and analysis. Let's look briefly through the agenda for this lesson. As I proceed through this lesson, we'll discuss how the Hadoop platform is powerful, but by itself, it's not sufficient to provide fast and meaningful insights on big data stored in Hadoop. Next, we'll see different approaches to big data reporting and analysis, along with various data access technologies. And finally, I'll give a quick overview of how a business intelligence or BI suite can operate using Hadoop. Throughout the course, you'll engage in hands-on lab exercises. You'll also get free BI and Hadoop software to use during the course, and the software is even yours to keep and use for free after you complete the course. Well, let's review the defining characteristics of big data. In particular, let's use Hadoop for our discussion. As you recall, massive volume, velocity, and variety, or the three V's, are the defining properties of big data. The Hadoop framework addresses all of these requirements. It provides a framework to scale out horizontally to arbitrarily large data sets to address volume. It handles a ferocious rate of incoming data from very large systems for velocity, and it supports complex jobs to handle any variety of unstructured data. But despite this ability to manage the three V's, the big challenge remains in figuring out how to analyze the data and find insights in this ocean of data. Hadoop does embrace the three V's, but the actual value of big data lies in deriving insights from these huge data sets to enable key decisions. So there needs to be an easy way to leverage Hadoop's power to further crunch through these data, make them more presentable and digestible. That's what drives reporting and analysis on Hadoop. Reporting analysis on Hadoop addresses the need to derive these meaningful insights quickly. So with reporting and analysis on Hadoop, we can make big data small to facilitate insights from the sea of data, reduce the time to unlock the business value of the big data, and simplify representation of complex insights. Also, BI suites can open possibilities of integrating a variety of external data sources, as we'll examine later. So given the need for churning through the data and then putting it into the hands of business users who can take action, let's have a look at how much of this process is actually handled by Hadoop. What we see here is the traditional data funnel. We've adapted it to the newer technologies used in the big data world. We start with the data production phase. Most of the big data is generated by servers in the form of logs, transaction records, web applications such as Web 2.0 and 3.0 applications, also sensor data and enterprise data from applications like CRM, ERP, billing systems, and so forth. The data produced in these enterprises today constitutes unstructured, structured, and multi-structured data, but it's all growing at astronomical rates. The next phase in the data funnel pertains to the storage and manipulation of these Herculean data sets. The users at this level of the data funnel are primarily data architects who design the enterprise-wide systems. The technology options for data architects at this level include Hadoop's distributed file system with map and reduce, HBase used as a data store, and the Hadoop data warehouse, Hive. Further down the data funnel is data analysis and data visualization. It's the phase where the big data is crunched to make it available to various user groups. This helps them make better decisions, and you may find the data analysts and data scientists working at this level. Typical job functions for users at this level include creating cubes with facts and dimensions to perform online analytical processing or OLAP analysis, visually representing the data that helps in spotting new trends and patterns. Not surprisingly, the technologies or tools for this functionality in Hadoop platform are not really sophisticated enough to support the job functions required in this level. The final layer of the data funnel is where the decision makers are looking for interactive, contextual reports, charts, and dashboards based on which they can make important operational and strategic decisions. We notice that there isn't much support to the data visualization, viewing, and data delivery layers in the existing Hadoop platform. So as you can see, this leaves Hadoop incomplete. Perhaps with the addition of a business intelligence suite that can leverage Hadoop, we can provide the much needed reporting and analysis on Hadoop. That makes it an end-to-end enterprise-ready solution. Well, let's discuss the various approaches to big data analysis based on the various use cases they can address. We'll show 3 latency-based approaches or use cases to draw insights from big data and Hadoop. The first approach is live exploration. An example of this approach could be a financial firm that's trying to hedge its investments and needs to look for real-time trends to make its decisions on financial market trading. That would mean discovering real-time patterns as they emerge from their big data content. So this use case has the least latency of the 3 approaches to big data. And this live exploration can be supported by a UI controlled by an in-memory engine designed to reduce any delays or latency. The next approach is direct batch reporting. This use case describes scenarios where the executives and operational managers look for summarized, pre-built periodic reports on the big data content. The reports generated here are typically of medium latency and targeted to user groups of executives and operational managers who might want to get reports on, for example, maybe which web content was the most popular over the last several days. Lastly, the indirect batch analysis. These are situations where business users would want to analyze historical trends like perhaps customer buying pattern by region and demographics, or maybe huge environmental data sets to determine optimal placement of wind turbine installation for green energy. These analyses are mostly based on slicing and dicing questions in the big data content. The business users here could be data analysts and operational managers. Okay, having discussed the various use cases for big data analysis, let's now look at the various technologies that can be put together to implement the individual approaches to big data, the ones we just discussed in the previous slide. As you recall, the first approach was live exploration of big data. That was discovering real-time patterns as they emerge from the big data content. So an implementation stack for this approach may include native connectors to draw data from HBase, the Hadoop distributed file system, and a user interface controlled by an in-memory engine for faster access to the insights. The second approach, direct batch reporting, was where the users viewed summarized, pre-built periodic reports on their big data content. A typical implementation stack here includes Hive connectors via which a report design tool like Jaspersoft iReport, for example, can draw upon data to design, generate, and schedule reports. Finally, indirect batch analysis. The expectation here is to analyze historical trends based on exploratory questions in the historical big data content. So the data here is brought using extract, transform, and load, or ETL technology, into either an analytical relational database or an online analytical processing, or OLAP, engine that can be used to gain insights of the historical trends. The three approaches are latency-based, with live exploration taking the least time, typically on the order of seconds. Direct batch reporting takes the medium latency, where the reports can be run in a few minutes perhaps. And finally, indirect batch analysis, which has the highest latency among the three use cases, where a data load and analysis could end up taking hours or even overnight. This is an architectural diagram representing our previous discussion on various data access technologies that can make BI reporting and analysis seamlessly operate on Hadoop. In the following lessons, we'll look at this in detail, and we'll use Jaspersoft Business Intelligence Suite to illustrate the concepts. You'll note here that Jaspersoft uses ETL, HiveQL or SQL, and also a connector to HBase. So ETL goes to a relational database. Hive uses a SQL-like language, but unlike Hive, there's no HBase query language. Rather, the data is queried using one of HBase's APIs, either the Java API directly or through the Thrift or REST server interfaces. We'll discuss all of this in detail in later lessons. Let's review for a moment what a Business Intelligence Suite typically comprises. This will provide some context for our upcoming lessons. The capabilities of a BI suite include reporting, which is designing interactive, pixel-perfect, and/or ad hoc reports for the web, the printer, or even mobile devices. Dashboards, where you would build multi-report displays with internal or external data for executives and knowledge workers. Analysis, where you would explore the data with powerful relational OLAP or in-memory analysis against any data source. And data integration, where you would build data marts or data warehouses from several disparate relational or non-relational sources. Later in this course, we'll examine each in more detail. So here's a preview of the upcoming lessons. For each use case approach, we'll discuss in more depth what it is, the importance of the approach, guidelines to help you decide when to use the method, and a demonstration of creating and reports and analysis with it, including a hands-on lab where you can create your own and get experience. At the completion of this Big Data University course, you'll have an understanding of the various ways to create reports and analytics on Hadoop, as well as hands-on experience in using a BI tool. Jaspersoft, the world's most widely installed business intelligence software, will be used as the example environment together with IBM Big Insights for the Hadoop component. Both products are free to use not only during this training, but also for your continued use free after you complete this course. We hope that you find this training to be enjoyable and useful, and we welcome your comments. When you're ready, please proceed to the next lesson. My colleagues are waiting there for you. Thank you for your interest.